Hello everyone, my name is Andre and I work at a coding and robotics company in Seoul, South Korea called LuxRobo. How do you detect the world around you? How do you know there are birds singing outside or there's a car on the street? You know because you hear or see them. We have 5 senses: touch, sight, hearing, smell, and taste. These senses are essential to our survival. They allow us to detect the world around us. Our senses detect specific information about our surroundings. We can also think of these senses as inputs. Without them, our brain would receive no information about the world. These are the 3 types of MODI modules that you saw in the video. We have 3 types: input, output, and setup. Over time, I found that the words input, output, and setup don't have that much meaning for someone that's new to coding and robotics. But when students play with the modules and see the related examples, they really understand how the function of each type of module actually makes sense. While they do hands-on activities, the students start to make connections and are able to begin creating their own project that solve problems. So now I'll introduce our modules. These are the different modules that we have in our kit. We wanted to let students make connections to their daily lives and to understand that these kind of modules are being used all around them in everyday life. For example, where can we find a dial? Or a speaker? Or how about a battery? I'm a little older and can remember using dials when turning up the record player when I was young. I can remember there are speakers on my Walkman or batteries in my cassette player. How do you detect the world around you? How do you know that there are birds singing outside or there's a car on the street? You know because you see or hear them. We have 5 senses: touch, sight, hearing, smell, and taste. These senses are essential to our survival. They allow us to detect the world around us. Our senses detect specific information about our surroundings. We can also think of these senses as inputs. Without them, our brain would receive no information about the world. So the ear detects sound, volume, and frequency, just like the microphone module. There are also microphones in smartphones, on stage when musicians perform, and in smart speakers in our homes. The eye detects light, specifically the brightness and color of light that reaches our retina. With this and other visual information, it helps us estimate distance. The MODI environment module also detects brightness and color of light that reaches the sensor. The MODI infrared module detects the amount of infrared light reflected by an object, which is dependent on distance. The closer an object, the more infrared light is reflected back to the sensor. There are lots of light sensors in the real world, like in motion-activated lights. These can be indoors or outdoors. Many cars have headlights that turn on when it gets dark. They even turn on in tunnels if they're dark enough. Most smartphones can change the screen brightness depending on the ambient lighting. A dim screen is no use in bright sunlight, right? When it detects bright light, it bumps up the screen brightness to match. We don't only have inputs though, we also have outputs. We use outputs to affect the world around us. We can move things with our muscles. They use energy and produce motion. The MODI motor module uses electricity and produces motion. Electric motors and fans help keep us cool. They help us get around in electric cars, and they help keep us safe at railroad crossings by lowering barriers when the train is approaching. Voice is one of the most uniquely human outputs we have. We can make sounds with our voice box and mouth. They use energy to produce sound. The MODI speaker module uses electricity and produces sound. We can find speakers in headphones, TVs, and at movie theaters. In addition to input and output modules, we also have setup modules. These support the function of other modules. Energy is essential for us and for machines. We use energy from food to live and interact with the world around us. We need energy for our senses to process inputs and for us to produce outputs. Just like us, MODI needs energy too. The battery provides the electrical energy that input and output modules need to function. Batteries come in different shapes and sizes, from the cylindrical alkaline batteries to button cells and lithium-ion batteries. But without the brain, nothing would work. We use our brain to learn and plan what we need to do. Our brain processes inputs from our senses and then plans and executes outputs. The network module uploads code to other modules so they know what to do. The code tells them how to process and interpret inputs and produce outputs. Computer chips are like brains for the machines. So to make a motion-activated light, we just connect a battery module, an infrared module, and an LED module. By just combining inputs, outputs, and setup modules, we can create a Modi version of other real-world products. For example, a battery module, a button module, and a motor controller module can make a fan. To make an alarm clock, you just need the following modules: battery, button, dial, speaker, and display. Add a bit of code and you're set. We were being told to wash our hands, wear masks, and to maintain social distancing. People kept asking and wondering, how long do we need to wash our hands for? During our trainings, we got lots of different answers. 1 minute, 60 seconds, 2 minutes. Everyone was confused. We realized that the answer was 20 seconds, but just by counting, we might not wash our hands for long enough, right? So we started to work on a project. We needed to do some computational thinking and break the problem down. Here you can see Jeanette Wing, who said that computational thinking is for everyone and a skill that we can apply to our lives. So we decided to follow the process of computational thinking and make a project that would help us with hand washing and stay safe from coronavirus. We started with everyday algorithms with students and got them to understand the process. We looked at brushing our teeth, so we went from decomposition to recognizing patterns, abstraction, and then finally taking out the parts we don't need. We then went back to hand washing and reworked the problem. We need to wash our hands for 20 seconds to kill the coronavirus. But how long is that? We can sing happy birthday twice, or we can use Modi and computational thinking to tackle the problem. So here are the steps of our algorithm, and here's how we will execute those steps. We will set a time using code, then we will start the countdown with the infrared module. The remaining time will be shown on the display module, and the user will be notified that they can stop washing their hands by the display module and the speaker. So here are all the Modi components that we will use. The battery will be our power source. The infrared module will be our on-off switch. The speaker will provide user feedback along with the display. Everything will be mounted on a basic brick for stability. Here's the final product. You'll notice there's an empty space in the basic brick. Think of that as an expansion slot. What else can we add there? We could add an LED module for a splash of color. We can even code a rainbow too. So here's our code. We're going to start with a variable, and we're calling that timer, and it's going to equal 20 for 20 seconds. An if block, when the proximity is greater than 30, we're going to start a while loop that's going to run until the timer reaches 0. And we're going to show on the display module how much longer the user has to wash their hands for. And now we're going to wait a second and then subtract 1 from timer. And when we're done, we're going to show a message congratulating the user, and we're going to play a tone using the speaker module. And last but not least, we're going to show a message that tells the user the instructions for how to start. So I'll show you just how easy it is to build the hand wash timer, and then you'll see it actually working. So we start with our basic block, and we put on the infrared in the corner, then the display, speaker, and a battery. That's it, with just a little bit of code that you just saw. That's how it's going to work, and in a second, there you go. We activate it using our hand. When we bring it close, the timer will start, and then we wash our hands diligently, and you can see the counter is updating. And when we're done, there you go. We get a message and a tone that tells us now we can rinse our hands.